Hello everyone, and welcome to this session, Building an Entity-Resolved Knowledge Graph, Why and How. My name is Jean. I'm one of the co-founders of Linkurious. So we are a company that specializes in graph visualization and analysis, and on a daily basis, more than 10,000 investigators throughout the world are using our products to make sense of complex connected data, aka graph data. So today I'm going to tackle three topics. First, what is entity resolution? Then different approaches to entity resolution, and then I will show a demo where we will apply entity resolution to the Panama Papers data. But first, what is entity resolution? So entity resolution is really the process of identifying when multiple records are related to the same real-world entity. So let's say, for example, that you have data about John Smith in database A, B, C, and you want to understand that indeed it's the one and the same person. Why is entity resolution even a problem? First of all, data quality in general is a problem. For actually almost one professional out of two, it's the number one challenge in all data projects. And there are multiple reasons for duplicates. It can be that the data is coming from different data sources, and that's what we were just talking about. It can be also that there's some natural data variations. For example, there are an estimated 33,000 John Smiths in the US alone. It can also be data entry errors. I'm Miss Smith. Calling a customer center to create a customer profile, and maybe there's some sort of fat finger error, and at the end of the process, Miss Smith ends up with two M's. It can also be that there are some cultural differences in data. So Miss Smith, it's going to spell differently in Mandarin, in Cyrillic, and in other languages. And then there can also be some temporal data changes. So let's say that Miss Smith marries, and maybe she becomes Miss Doe. And then sometimes there can be also some international misinformation. So Miss Smith wants to commit some crime, and in order to do so, she uses an alias, Miss Molly Queen. So a lot of different reasons to end up with duplicates in your data. And why entity resolution is important? So first, it helps improve the quality of data, which has effects on everything that relies on the data. So it can be better reporting, more accurate analytics, but also just a better customer experience. But entity resolution is particularly relevant when it comes to risk-related investigations. It's particularly relevant for three reasons. The first one is that it improves the ability to detect criminal behaviors, such as rings of fake identities. It can also help conduct faster investigations. It's easier to find the records that are related to a given entity, a given person. And then finally, it unlocks the ability to enhance internal data with external information about politically exposed persons, company ownership, and so on. I want to illustrate all of these concepts now using a simple example. So we are going to be leveraging entity resolution to uncover some risks. Here we have two companies, Mom Corp and Acme Inc. And they're controlled by Mr. Smith. I can get all of this information using my internal data. But maybe I'm able to use entity resolution to figure out that Mr. Smith in gray, it's connected to the Mr. Smith in blue because it's the same entity. And that information is coming from maybe a company registry. And then with the same source of information, I can identify that Mr. Smith is indirectly connected to Mr. Zukov and Mr. Gavian. And if these entities are risky, then all of a sudden it means that both Mom Corp and Acme Inc. are also risky. And that's the sort of insights that can be uncovered using entity resolution and graph analytics. There are different ways to tackle entity resolution, and I want to talk about these different approaches. So, for example, there are some lightweight data quality and integration software out there. They use simple techniques such as basic data matching on exact ID numbers. Here you will have low accuracy beyond simple use cases. It's also possible to build something proprietary, and then it becomes an internal project. And depending on your requirements, it can scale to dozens of engineers with some question marks in terms of the budget that this comes with and the time to market. And finally, it's possible to buy some legacy entity resolution products out there. And then you have to spend significant money on the software itself, the hardware, professional services needed to configure all of that, train and tune these products. And that's expensive and also comes with some changes in terms of time to market. And I want to zoom in on the do-it-yourself approach and talk about the fact that it's fairly deceptive. It's deceptive. Why? Because it's easy to get started. But at the same time, in enterprise projects, there's typically a long tail of requirements, such as multi-source, multilingual, configurable, accurate, scalable, explainable, cloud-ready, real-time, low latency, easy to use. At the end of the day, that means that it's non-linear to build a system that addresses all of these requirements. You can get something that addresses 70% of the requirements for $1 million. But then if you want to scale up and tackle an extra 20% to get to 90% of the requirements, then you're potentially looking at more than $30 million in spending. And after that investment, you still won't have something that's competitive. So let's illustrate the benefits and the issues with the do-it-yourself approach using the Neo4j-based entity resolution example. So it's possible to build an entity resolution engine based on Neo4j. It's possible because within Neo4j, you have the ability to compare words using, for example, phonetic distance. You also have the ability to identify similarities based on node properties or on neighbors. But it's difficult to build on these primitives a production-ready system that can scale. And these techniques that are available in Neo4j and GDS, they don't really cover the long tail of requirements that I mentioned previously. So at the end of the day, it means that it's easy to get a prototype up and running. It's a significant engineering effort to put it in production, and then you still will have something that tackles most of the requirements. So it's a bit of a trap, really, when you think about that. For that reason, we have decided to partner with Sensing to help to facilitate the ability to build entity-resolved knowledge graph. Sensing is a purpose-built AI for real-time entity resolution that's based on an entity-centric approach. And starting this quarter, Linkurious is integrating Sensing to perform entity resolution on top of Neo4j stored data. The Sensing ER process does two things. First, it helps find and consolidate duplicate entities. And secondly, it helps discover hidden connections across the entities. Entity-resolved knowledge graphs produced via Sensing can help investigators more quickly understand the data and find previously hidden and impossible to see connections. So I mentioned the entity-centric approach, and I want to get back to that in more detail. The traditional approach to entity resolution is record-to-record matching. You take two pairs of records, you compare them, and you figure out if it's the same entity. But there are some issues with that, and we can see that with an example. So here we have a new record in blue, and if we try to compare it with these three records here, it's not going to be possible to find a match. It's not going to be possible to find a match because the name, it matches with record 3, the address, it matches with record 1, and the phone number, it matches with record 2. But every time we have a partial match, it's not possible to confidently resolve the entities. By contrast, the entity-centric approach, it consists of creating an holistic understanding of the records, combining the various pieces of information. And then when that new record comes up, we see that we have matches across 3 pieces of information, and we can confidently resolve the new record with the previous records. So that's the entity-centric approach and its benefits. So now let's talk about how it works in the context of Linkurious Enterprise, how we integrate Neo4j and Sensing. It all starts with an admin that needs to configure the mapping between Sensing and Linkurious Enterprise, the data mapping. Then the data, it's ingested in the graph database through an ETL process. And that data, it's sent by Linkurious Enterprise to the Sensing engine. So the data flows from the database to Sensing. And then the sensing engine detects entities, and these entities, they are connected to the relevant records and updated by Linux Enterprise in the graph database. What that means is that at the end of the day, the end user, when that person opens up visualization or a case, he or she can see the duplicated records very, very easily, and we will see that via demo later. And this has significant benefits. First of all, it's entirely graph native. There's no complex data preparation. The data is entity resolved as it sits on the graph. There's also no required expertise around entity resolution to apply that. And because of these two things, then the total cost of ownership is very attractive. You don't need to have an army of engineers, a lot of complex hardware. It's very easy to get up and running. Similar additional benefits include the fact that it's completely continuous and real time. As new data comes in, the entity resolution process is performed. Sensing is highly scalable, meaning that this approach can scale to billions of records. And something that's also important is that it's explainable. When records are entity resolved, it's possible to understand why so, which is very important when you have sensitive data and sensitive decisions. Okay, so we have talked about entity resolution in theory. Now let's talk about that in practice, and we will use a demo where we will be applying entity resolution to the Panama Papers. So we are going to be using the IC offshore database. So the ICIJ is a consortium of data journalists that specializes in offshore banking and financial crime investigations. The ICIJ offshore database, it's really a mix of 5 different data leaks, and this data is open source, and it contains, among others, more than 400,000 addresses, more than 800,000 entities, so it's very significant. And interestingly, a first level of entity resolution has been performed by the ICIJ, which gives us a bit of a benchmark that we will be able to use later. So now let's talk a little bit about the data. Here you can see the data model, or at least a simplified version of that data model. So up top, we have an address. That address is connected to an organization, and that organization is connected to two persons. As I mentioned, a first level of entity resolution has been performed by the ICIJ, and typically you have relationships between records that are potentially similar. Here you have the same name as relationship between these two records. What we have done is that we have streamed the data through sensing, and we have added an extra node that represents the real-world entities, and we have connected this extra node here to this record, and this record represents the fact that the records are actually related to the same real-world entity. So this is, in a nutshell, the data set, the data model that we will dive in a few seconds into via linkers. But first, just a quick overview of the data and the impact of the entity resolution process on that. So we have almost 1.9 million individual entities that have been identified via the entity resolution process. Out of that, we have 1.84 million singletons. So these are records that are not connected to anything else, that are unique. And then we have 130,000 duplicates. So it's entities that are connected to multiple records, at least two records. And the compression rate in the data is 4.1%. It means that if you were to take a sample of 100 records, you would have 96 real-world entities with some duplicates, I guess. So that's it for an overview of the data. Now let's dive into the demo itself. So we are going to be using Linux Enterprise. It's connected to a version of the ICIJ offshore database that's been entity resolved with sensing. We are going to see a couple of things, starting with before after the entity resolution process. Then we will compare some results that have been entity resolved via sensing and via the ICIJ process. And finally, we will review some duplicates together. But let's get started, and I'm going to switch to the Linkers Enterprise UI. So this is my dashboard, and I'm going to open a first visualization. Double-clicking on that. Okay, so here we have a set of nodes, and we actually have 71 officers and two entities. If I'm just looking at this data like this, I may think that we have 73 distinct nodes with just one single relationship. So mostly, it's just a bunch of unconnected nodes. But I'm going to go ahead, select all the nodes, and I'm going to expand and retrieve the sensing entity. So that sensing entity represents the real-world entities, and that's what we have added to the data via the entity resolution process. And lo and behold, we don't really have 73 distinct entities. We actually have 10 entities and 73 records. And I'm going to give you an example of what I mean by that. Here we have William Michael Valtos Jr. And it's one person, but it's 1, 2, 3, and 4 distinct records. And via the entity resolution process, we've been able to connect all of these records together via this node. And we understand that it's not really distinct, discrete entities, but it's just one and the same entity. And we can see that across the entire visualization. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 sensing nodes, so 10 sensing clusters. So that's the sort of insights that entity resolution can help bring. It can help move from this view of very disparate and connected data to something that's more concise, more reflective of the reality, where we just go from 73 distinct nodes to 10 real-world entities. And then using some of the features of Linkers Enterprise, for example, it's possible to group these different clusters to make it easier to see what's connected to what, and really pivot from these 73 distinct nodes to the 10 real-world entities that are actually in the data. So that's one first example of applying entity resolution to some graph data and to the ICIJ offshore graph database. Now I'm going back to the dashboard, and I'm going to show another demo. This time we are going to be looking at some false negatives. So I'm still in the Linkers Enterprise UI. I'm clicking here, and I'm opening up a new visualization. Zooming out now, and we have a couple of subgraphs that we are going to look into together. So first subgraph, we have Peter Michael reader gaze. Peter Michael reader gaze, another one. I can see the details in this panel. We have yet another Peter Michael reader gaze. And we can see that these two records, they have been connected by the same name as relationship. So the ICIJ entity resolution process has effectively identified that these are probably the same records. But as you can see, this Peter Michael reader gaze is not connected to the other records. So if I was to remove the sensing nodes, I would be left with two separate graphs, one graph here and another graph there. And depending on my skills and time as an investigator, I would be able to connect the dots, understand that these nodes are connected to that node or not. Whereas with the sensing node and with the entity resolution process accomplished via sensing, I'm able to understand that indeed these three records are all interconnected. And if we zoom in, we can potentially figure out that this record hasn't been connected with the other records because of that mister that creates a difference between the names of the three records. Okay, so that's what I would call an example of a false negative, meaning that this node here hasn't been identified as a duplicate of these other nodes due to a limitation of a basic entity resolution process. Let's look at another example now. So here we have another example, a cluster where we have 1, 2, 3, 4, 5, 6, 7 Fiano Anastasiadi, so probably a Greek-sounding name. We can inspect, the various nodes, but what stands out for me is the fact that they are only partially connected once again. So they seem to all share the same address and very similar sounding names. But there are some small tweaks. So, for example, here it's Anastasia D versus Anastasia Ziadou here. The bottom line is that the entity resolution process used by the ICLJ only that identifies two duplicates, these two records. Whereas with sensing, we are able to combine all of these different records into a single entity, which helps streamline the analysis and the investigation process. Okay. Another example. So here we have two cock-wing junior limb with a name that's spelled out slightly differently, and as a result, these two nodes are not connected by the ICLJ entity resolution process. But the combination of the similar name, the fact that they share an address, and a company means that sensing is able to successfully resolve these records and identify that it's one and the same real-world entity. So these are three small examples that show the difference and the value of a fairly simple entity resolution process versus something more advanced, like the type of entity resolution that can be accomplished using a technology such as sensing. Going back to the dashboard now, so we have seen a couple of examples. I want to show another one. This time, we are going to use alerts in Linux Enterprise to surface some potential clusters and provide the ability for humans to review the data and provide some input on that. So first, I'm going to open up this alert, this Linux Enterprise alert. Okay, I can see the code that's powering that. Basically, we are trying to identify when multiple records here are connected to a sensing entity. In this case, we take that sensing entity. We collect everything that's related to that, and we also count the number of distinct records that are connected to that sensing entity, and that becomes a score. And then we return everything when the score is above 1. So that's the alert, and then we can see the results that it generates. And maybe I want to focus on the entities with the most duplicates. I can take this one as an example. We see that it's a sensing record that has been identified as connected to 59 records, and I can open it and see what it looks like. Inspect. Figure out whether there's something wrong going on or not. If I want to, I can, add some comments. So it's a very easy way and very effective way to combine the power of AI to do some resolution, but also have human in the loop type analysis when it comes to entity resolution. Okay, going back to the case list now. So that's it for the demo. We have seen a couple of things. We have seen the before and after entity resolution, the impact that it can bring. We have also seen how the type of entity resolution performed using entity resolution, using sensing compares with a more simple approach. And finally, we have seen how using alerts, we can combine the power of entity resolution with manual input via alerts. Okay, so that's it for the demo now. We have some extra time, a couple of minutes for questions.